Hello students, we're going to do a reflection problem. So we're going to do one that is for a concave mirror. And you can do a reflection problem for a flat mirror or concave or convex. They're done very, very similarly. Don't be intimidated by the number of terms that I'm going to put up. They actually do kind of make sense a little bit. And once you go through it maybe once or twice, then you'll find out that it's not really a big deal at all. So what I'm going to do is I'm going to put a list of the terms that we're going to use, the variables that we're going to use for doing reflection problems, right? So you may want to pause the video at that point if you haven't already copied them down. And then I'm also going to put up the problem that we're going to do, and then I'm going to walk you through how to do the problem. Okay, so they're really not a big deal. They look a little bit differently from some of the other problems, but I have no question that we're going to be able to get through it. So here are the terms, and here is the problem that we're going to do.
Okay, so I have the mirror equation here, 1 over f equals 1 over p plus 1 over q. And you know that little f, now that you've read those terms, is the focal length. And little p is the distance that the object is from the mirror. And q is the distance from the mirror to the actual image. So for this particular one, we have a concave mirror, and there's a person 25 centimeters in front. So that will be what p is equal to, 25 centimeters. And it said that there's an image 50 centimeters behind. And because it's behind, I'm going to make that negative, right? So negative 50 centimeters. It's a concave mirror, so I'm just going to write that down. And we're asked to find what is the focal length. We're also asked to find the radius of curvature, what is the magnification, and then what is the type of image that we see. So I'm just going to take my lens equation, 1 over f equals 1 over p plus 1 over q, and I'm going to put all of the numbers right into this. So here's the equation that we're going to use. So I've got 1 over my 25 centimeters plus 1 over my negative 50 centimeters. And then I'm going to use 1 centimeter as the common denominator for both of these. And so if I do 1 divided by 25, I have 0.400. I've got over here plus a negative, which is really going to be negative. And then our 1 divided by 50 is 0.0200, and that's also over 1 centimeter. So why would I do that? Because 1 over f, I need to find f, but I need a common denominator if I'm going to be adding these fractions. Of course, you can do this with your scientific calculators and you'll have no problem at all. When we combine those together, we get 0.0200 divided by, or over rather, 1 centimeter. So I want to find what f is equal to, not 1 over f. So f equals, all I have to do is just flip this over. 1 divided by 0.02 is going to be 50. So my focal length for this mirror is 50 centimeters. So what would the radius of curvature be? Well, the radius of curvature is going to be 2 times the focal length. So I have 2 times my 50 centimeters. No surprise, we've got a 100 centimeter radius of curvature for this particular mirror that we're looking at. Now, we do have a couple of ways that we can figure out what our magnification is. And in this case here, because I have our image and object distance, I can use the magnification equation that has minus q over p. So if I put the numbers in for this, I have minus. Now remember, q is also minus, so I have minus 50 centimeters divided by our 25 centimeters for our object distance. And we can see that this is simply going to be positive 2. So this is our magnification, right? The object that we see is 2 times bigger than what it actually is. And that also tells us the type of image that we have too, because if I have a positive magnification, then the image will be virtual, and every virtual image will also be upright. If, on the other hand, I had a negative magnification, the negative magnification would tell us that we have a real image and it would be inverted. So there you have it. That is our sample problem for doing our lens or mirror. It's actually the same equation that we would use. This will work for any type of curved mirror. In this case, we have concave, but you can certainly also do this for convex. So let me know if you have any questions.